Hi, I'm Paul. Welcome back to Science That Sticks. Let's learn about atom economy. Roll that graphic. Hi there. Now we're going to look at atom economy. It's different to percentage yield because percentage yield is an expression of how much you actually made divided by what you thought you were going to make times it by 100. And obviously the closer you get to 100 is how much you actually obtained as a percentage. Pretty easy stuff. Atom economy is similar to this in as much as you end up with a percentage. However, to get the atom economy, you need the relative formula mass of the molecule that you are trying to make. Once you've got that, you divide it by the total relative formula masses of all of the products. That will give you an actual percentage. Now you could do that by the reactants as well, but the whole thing should be the same both sides of the equation. Let's look at the equation and then let's look at some examples. So, the equation, atom economy, relative formula mass, molecular weight, RMM, whatever you use, whatever your teachers use, it's going to be the same thing. The sum of all of the relative atomic masses in that molecule divided by the sum of all of the reactants or all of the products, depending on which one you want to do, added together. And then you divide one by the other, then you multiply it by 100. I'll leave that bit in. Let's have a look at some examples. So what I've done here is I've wrote out all 4 of the ways of making magnesium sulfate. You can react it with the metal oxide, the metal carbonate, and the alkali, the metal hydroxide. You need to react it in every case with sulfuric acid because it's the sulfate salt that we want. The next key feature that you need is the relative formula mass of your desired product. We want the relative formula mass of magnesium sulfate. It is 120. Why is it that? Simple. Magnesium, relative atomic mass of 24. Sulfur, 32. Oxygen is 16. There are 4 oxygens in sulfate, 1 sulfur. Add all of that together with the 24 gives you 120. That's our number there. If we add the 2 on for hydrogen, it becomes 122. That's the total relative formula mass of all of the products of the first one. So this division becomes 120 divided by 122 times it by 100. And that gives us an atom economy of 98.3%. That's pretty darn high. If we then calculate the rest of them, we could then compare which one we might particularly choose. But then we've got to consider some other factors. So what I'll do is I'll do these out first and I'll put it in time lapse so it looks like I'm really racing. Now that was pretty quick. Let's look at these percentages. If we have just reaction number 1, the metal with the acid, we get a 98.3% yield. That's really high, and there's some good parts and bad parts to this. The good part is that you've got a high atom yield. The downside of it is that getting magnesium is really costly. Not only that, but this reaction is very exothermic, so it's going to generate a lot of heat. Hydrogen's also flammable, but it's also useful as an economic byproduct. It could be that you'd use this to make hydrogen, but you also get that as a byproduct. So there's pluses and minuses. The base reacted with magnesium sulfuric acid gives us an atom yield of 86.9. magnesium oxide. You might be able to find that in an ore, in which case it's much easier. You don't need to react it to get, or electrolyze something to get the magnesium, in which case it's easier. The same is true for the carbonate. Magnesium hydroxide on the other hand, well, that's going to take a bit of effort to get a hold of. That's going to require a separate chemical reaction before you can make that. So you might want to think about what you have to begin with. Now, in this case, if we're just looking at the percentages, you've got to go with the top one. But normally in an exam, you'll be given a few more bits of information. So read the exam question, use your common sense, and until next time, as always, stay cool. Bye for now.